And we're back. Welcome back, everyone. I think some people are still coming in on the back side. To the audience, welcome back as well. I think the camera is looking at Benjamin over there. I don't know why. Hey, man.
It's just not ready for me.
Yeah, the
like,
camera's not ready.
Nope.
But the screen share should work. So we're going to start off with this session about the dangerous side of Kotlin.
Yeah.
Spooky. Bart Enkelaar, everyone. Enjoy.
All right. Hello, everyone. How are we liking Kotlin Dev Day so far? Yeah. All right. We're getting some energy here. All right. Let's go. So this is me and my wonderful sons across the eye here. My name is Bart Enkelaar. I work at bol.com. I work there as lead site reliability engineer. You can find me on Twitter, and if you have any questions after this presentation or after you've slept on it, you can always mail me at this email address. And all the slides and the code used in this presentation is on GitHub. You can find it right here. So, yeah, I think most people will know what bol.com is. We're the largest online retailing platform in the Netherlands and Belgium. We're part of the Ahold Delhaize group, and we have a wonderful headquarters in Utrecht, where we work with about 2,500, I think, these days. Colleagues ask me next week, it's going to be more. Of which 600, 700 are in doing development on our back-end systems and front-end systems. Yeah, we sell anything from toys to pet stuff and anything else that's not food, because that's what Ahold does. I mean, Albert Heijn does, yeah. And we ship like, particularly this week, particularly tomorrow, we ship thousands, hundred thousands of packages out of our warehouses in Waalwijk, and there's some other locations, but most important ones are in Waalwijk. And you can imagine that that's a really exciting and interesting software landscape to work in, where we have easy 1,500 microservices, all interacting, all with all different kinds of programming languages, architectural models, collaborating, and it's a really fun place to work. So if you're looking for a job, come join us. Yeah, and as I said, tomorrow is Black Friday, so we've got everything's on, I would say high alert, but actually we try to organize it so that we have the most boring Black Friday attack every year. And last couple of years that's worked really surprisingly well. Right, let's talk about rockets. I love talking about rockets. And yesterday morning, 7:20 a.m., me and my son were looking at this wonderful rocket launch of a SpaceX Falcon 9 that was sending the DART mission into outer space, the double asteroid redirect test. And I really love this mission. I love SpaceX for the awesome innovation that they're doing in the rocket space. But this particular mission it's a NASA mission, and it is going out, and it's really going to try to see if we can do what the dinosaurs failed to do. As in, if an asteroid would be coming for the Earth, can we deflect it in such a way that it just whizzes right on by and we can get to live on instead of what the dinosaurs did. So yeah, I think this is an amazing example of forward thinking, which is something that not always gets enough room in our current society, especially with all the crises that we have right now. There's a tendency to look at the now and stay in the now, and this is one of those particular things that is looking at the future and preparing for it. So I love this mission, and I'm going to be coming back to why it's in any way, shape, or form relevant to my presentation. Besides, of course, that it's awesome. Right, so let's talk about Kotlin. That's why we're here, right? And we have been talking about Kotlin, and we've heard all kinds of awesome stuff about it. So right now, let's talk about dangerous Kotlin. Where you go? Here, there's a dangerous fella over there. So when I say dangerous Kotlin, I of course don't mean like running with the bulls, risking your life, and I also don't mean like hacking and going illegal and stuff like that. Because you could probably do that with Kotlin, but please don't, you know. So what I want to talk about when I say the dangerous side of Kotlin, so the dangerous side of Kotlin. What I really mean much more is in the nature of programming languages, because over the last 40, 50 years, programming languages have successively grown in abstraction and grown in power, and I really think that Kotlin is a really interesting next step when you compare it to something like Java. And if you look at fundamentally what we need from a programming language, so code, Kotlin code, awesome. So fundamentally, what we need from a programming language is, I think it's three things, right? It needs to fix our problem for us, which, I mean, that's basic. Any Turing-complete language can do this for you. But then the other thing is that it also needs to be easy to write, because we don't just want to fix our problems, we want to fix our problems fast and efficiently. And then even more vital, because all code gets read like thousands times more than it gets written, is that it should be easy to read. And I really think that in this last aspect, Kotlin has shown itself to be like the superhero of the JVM world, where it has really found this interesting balance between powerful features, but optimizing like the pragmatic use case that keeps it simple and easy to read, mostly. Like, you know, things from Tony Hoare's $1 billion mistake, you know, that they've baked that into the type system. That's absolutely awesome. And things like data classes, but of course Java has that these days, but still it works great. And the operator overloads, there is type aliases, functions as a first-class citizen of the type system, great. And other things like type reifications, extension methods, all kinds of cool, powerful features that give you the ability to make expressive code that is just easier to read. So that's why we love Kotlin, right? But with all these different tools that we get from Kotlin, there comes a risk, because, you know, we had Spider-Man up there, like, with great power comes great responsibility. I mean, it's true. It's a cliche because it's true. And all these different tools might make it hard to select the right one, because the more choices you have, the harder that choice is to make. And that's why Kotlin is better than Scala, because Scala had just too many options. So let's talk about a couple of them and see how they can sometimes hinder more than help. So let's talk about extension functions. By the way, I'm going to be talking about a couple different features, and then I'm going to be wrapping up why I think it's dangerous. And after each one, there is room for questions. So I'll throw that in there. So we all know what extension functions are. We've seen them a couple times already in presentations. You can do stuff like, for example, this. If you want to convert a string into a URL, you can do that like, okay, do this as URL, and then you get a URL. But if you do that, maybe somebody else does this somewhere else in your code base. And maybe in a third place in the code base, you have this one, which actually silently swallows malformed URL exceptions. And now you have like the same functionality in 3 URLs, and you might actually, that somebody else calls as URL, well, he's thinking that he's calling to URL, and you get like hidden different types of behavior, all kinds of, over your code base. While what you want is, you want your code to be easier to understand. But now you have duplication. Maybe. So this is a risk from extension functions, and I've even seen a team do this, where you have like a data class, and then basically all methods on that data class are extension functions, and it's like, I guess you get some form of like what you have in JavaScript and TypeScript, that you can only import the methods that you need, but that's probably at least object-oriented wise, that's not an advantage at all, because you want your methods on your object to be highly cohesive with your object. So please don't do this. And right, yeah. So how should you use it? So imagine Mikla did this all the way right just earlier. You have a monetary value, so you want to use a big decimal, and now that big decimal, you want to multiply it, and you can't. But of course, IntelliJ is great, and already suggested, hey, I can fix this for you with an extension operator overload. And then you build that. But now you have this extension function in your code, and I've literally seen this extension function at 5 different locations in the same code base. It's like, okay, so what then should you do? Well, you can, of course, do something like this. You create an inline class that actually encompasses the actual concept that you're trying to model here, and then put your operator overload in that class. And by this way, you have a centralized location for your concept, and you can put all your operator overloads, your methods in that new concept. And now you have a new cohesive object that makes your code easier to understand and lives in only one location. So whenever you're adding extension methods to externally defined types, ask yourself if maybe what you're doing here is turning that type into a different type of concept that would be better served by actually putting that concept in your code. I know there's problems with this implementation. That's right, so extension functions. They are great, but they can introduce duplication, and often do. They can break encapsulation, as in if you do an extension function that overrides a class, you actually have different behavior purely because of an import, if someone else imports that extension function. So that, I mean, that's also like almost Scala implicit like, right? So that could really hide what's going on with the object. So once again, I would like to stress there, a dedicated object is usually better, is often better. And as such, they really can interfere with object-oriented principles. But of course, so when is it great to use extension methods? When you have like a semantic conversion or functionality of an object that is truly only relevant for the context it lives in, then having a private extension function there makes total sense. Like the default use case is mapping domain entities to DTOs. Then you just want to have a private extension function on your domain entity in your controller or wherever you're doing the conversion. And that makes total sense. Because that really doesn't belong with that object. That belongs with the transport layer. So if you have logic that you semantically want to add to the object, but doesn't belong, but really belongs to the concept you're living in, then it makes sense. But otherwise, maybe a dedicated object could be a better solution. All right, so any questions about this?
How does it introduce duplication where other scenarios don't?
Yeah.
I mean, if it
yep.
basic,
I
think it's off, but
yeah.
If you have
yeah, you're saying if you introduce the money class, then someone else might still do the big decimal or time somewhere else.
As long as you keep your extension method, like if you're doing something in a class,
yeah,
and you want to, and you're introducing a private extension method for something that you would otherwise code manually, and you do something similar in a different class, how is that different from doing it inline in both classes, or making an internal function in both classes? Why would I do it more often when we have extension functions versus when I don't?
Yeah, so you can make all these mistakes with normal functions as well. That's definitely true. It's just that, at least to me, what I've seen in code bases I've worked on is that extension functions, they really give you this capability to turn an external type into something that is slightly different. Because it like locally adds this functionality onto the type. And I'm not saying that if you have these duplicated internal functions that you don't have that problem. I'm just saying that if you do this with external extension methods, then you have a clear code smell, I think, that maybe you need to introduce a new object there. So does that make sense? So it really doesn't indeed introduce more duplication than you would with inline function, but actually it makes the problem of the duplication clearer. Okay. So maybe that's actually a benefit.
Well,
but
actually, the fact that it's so nice to read, I can actually see the issue, because it's so nice to read that you don't feel the need to make a separate type as quickly.
Exactly, exactly. Yeah, so that's also where I'm gonna come back to later. So any other questions?
There's one from the chat, but let me check if this mic is on. Because
right.
It is on, right?
Okay.
Yeah.
Just eat it when you say talk into
exactly.
it.
let me read this aloud. From Amir Mohamed Vosso, you mentioned you have too many extensions, lookalike functions, which would be confusing. But what's the difference between that and having similar static methods in Java?
Yeah, it's basically the same thing. You can make all these mistakes with normal function. Yeah. It's just, I think what you said is very apt, that the seductiveness of its semantic readability makes it more pronounced with extension function.
Cool, thanks.
Cool questions, thanks. All right, so yeah, certified danger. I forgot to put the stamp on it. There we go. So let's talk about operator overloading. I just showed you an example where I said, oh yeah, this is awesome, you can do it in the type, but it's not, it's one of these things, yes, powerful, but, and here comes the but. So yeah, here I showed you where I think this is pretty cool. It's because doing math with money makes lots of sense. And yeah, that one, yay. But if you're like me, yeah, the story doesn't quite line up with the slides now and then. So if you're like me, then and you really like math, then at some point, because math is the ultimate abstraction of the universe, right? It's in the end you can express everything in math as long as you ignore enough details. And but that tends to push people like me to think about everything as math equations. And there was this project, yeah, so that makes our mental model of things to be math, because all these details that the math ignores, you've internalized them and by default brought them along in your way of thinking. And operator overloading allows you to express this internalization of these details in your code in a way that hides them completely, which might not be a very good idea if somebody else tries to read your code. So let me tell you a little story. I was working on an application that was responsible for all the goods going into our warehouses and out of them, and was trying to figure out what we paid for those goods. It's surprisingly difficult to figure that out, because we get, like, people send us goods that we never ordered, and goods drop off wagons left and right, and if it's long in the warehouse, then it's actually worth less, so you have to take that off. It's yeah, surprisingly complex. And but eventually we take boxes, we put a price on them, items, and that means we have stock transactions, goods coming in, going out, moving, getting lost, all kinds. And we have price transactions, like we figure out, or we think that we bought this for this offer, or maybe we bought it for this offer, and maybe we have this kind of rebate on this offer if we sell enough, stuff like that. So we have both stock transactions and price transactions. And then what we want to know in the end is how much is our total stock worth. So these stock transactions and price transactions turn into stock value transactions. And I explained this story while we were working on this to people, new people joining the teams, to other business owners. I explained it many times, and every time, in the end, it resulted into me scribbling something along the lines of this. So you have an X amount of stock transactions, and you have a Y amount of price transactions, and that turns into an XY amount of delta V. So you have your delta stock, your delta P, and you sort of cross-product that, and you put that, you end up with a delta V. So this was the way I thought about this. This was my mental model of that problem. So then this was the first application I was using Kotlin in, and I was so excited when I figured out I can express this problem like this. I was like, yeah, this is exactly how I explain it to everyone. This is how we think about it. This is the solution to my problem. So I put it in there, and I was like, yeah, really proud. Like for a week, I was telling everyone about operator overloading. It's like, it's so cool. It makes your code so expressive. And then, like a month later, an ex-colleague from a previous company, who was an amazing software engineer, joined our team, and he was looking at this code. I was like, what the hell is going on here? It's like, so okay. This is a math equation, so A times B is C, right? That's what you expect when you see this. But what was actually going on is this stock transaction list. That was a complex list of complex objects with references, fallbacks, and the price transactions, same things. And some of these were linked, and some were linked to external systems. And this multiplication it wasn't a multiplication operation. It was you link is and you look up you look for certain identities. You query other systems for possible relevance, you query the database for possible relevance. So there was a world of things happening here. None of that was in this line. So, he had no clue what was going on. He's like, can we please rewrite this? And I was like, hi, you make a valid point. So, operator overloading. It's great, it's awesome. It can allow you to do math on things that it makes sense to do math on, but not everything makes sense to express as math. It really works well if you have a number that is countable, that you express with a richer type around that, and as such, because otherwise it will surprise your readers of what is going on. And this is what we had earlier about the extension methods. It's just risky for its seductive elegance. You're like, oh yeah, it's so little characters. So, any questions about operator overloading? No? All right, let's go. Yes, I keep forgetting the stamp. Danger. So let's talk about lambdas with receivers. Nicola showed them, and I think Nicolaus as well, because yeah, these are your go-to tool for DSLs, I think, in Kotlin, and like, yeah, I think by now everyone knows what lambdas with receiver are. That you execute the context of your lambda within an externally defined object. And this was one of the locations that I used them. This was some test configuration code where it's a pub/sub adapter, and on production the topics and the queues, they're created through an externally defined infrastructure configuration system, but locally against an emulator we had to create them, and we wanted to do this idempotent, so we delete them first and then we create them, but if they're not there, then the deletion is fine to fail. So that's what this ignoring not found is about. And you know, originally we had like catches in multiple locations. We're like, this is duplication, I want to get rid of this, and I came up with this solution. But there's a particular interesting thing happening here, where you have this extension method that receives a lambda with receiver that is then being called on the body of that extension method that it is being called by. So that basically allows us to put this intermediate method between a function called on the pub/sub admin. And the nice thing about this is that it allows IntelliJ to keep up with us, and it does actually do code completion within the ignoring not found block. But to a reader, you have no guarantee that this function that's passed into the ignoring not found is actually being applied to the object that you're calling ignoring not found on. So when I try to explain this later because pretty much everybody else who read this code was like, yeah, I don't understand how it works, but I understand what it does, so never mind. Which, on the one hand, is okay, because at least they understand what it does. But if somebody else would need to change this, yeah, I would probably just delete this and start over. So, because like fundamentally, what this does is it turns Kotlin into JavaScript. And for JavaScript, it's always this joke that I love. And by now, at least I showed this on JFall, and like 5 people came back to me with, oh, it's this tweet. And it's like, am I that bad at Google? But okay, so I actually have which tweet, and there's multiple, but I didn't put it in the presentation yet. So, but yeah, this is my main gripe with lambdas with receiver, and that mostly boils down to that. Yes, it allows your IDE to do proper code completion, but if you need your IDE to tell you what your code can do, I'm not sure if that's good enough. You know, you won't always have the context of your IDE if you're doing a code review on GitHub or GitLab, or you know, it reduces the expressibility of the code itself. So yeah, that's lambdas with receiver. They're great for DSLs, but they obfuscate context scope, as in you have no guarantee on what object the lambda is actually being called. And as such, I saw a presentation of Venkat once. I'm not going to try his last name, but you know who I'm talking about, right? And he will say, like, whenever I've written some code and I think, oh yeah, this is smart, then I delete it. And I think pretty much all code that uses lambda with receiver doesn't pass that test, because you can do nice things with it if you think about it hard enough, and maybe that's not a burden that you want to put on the readers of your code. And as such, it turns Kotlin into JavaScript, and nobody wants that. So, certified danger. Any questions about lambdas with receiver? Yeah?
I actually like your example.
Okay, thank you.
So, no, I mean more like, I don't find it a danger in this specific case. I would be okay with that code.
Yeah, but it's, I think, only because they live so next to each other and they're so private. And it only takes one other person adding like a different private function there to maybe lose that connection. And then maybe someone else refactors it into, like, oh yeah, I can use it somewhere else. And now suddenly you've lost all that connection. And so I think it's kind of a slippery slope situation. But yeah. Any others? Cool. Then what are we doing for time? Oh, excellent. So, if you're like me, and you were a teen in the 90s, then you definitely saw I don't want to miss one thing, Armageddon, right? And because this is the story of that asteroid impact, and like, oh, size of Texas, 18 days, we have to fix it now, nuke it, which like on different levels is not very realistic, but it was a great movie. And we were all rooting for Liv and Ben, right? Yeah. So, but what they're doing here is they're throwing nukes at it and they're just blowing it up. And yes, nukes are more powerful, but NASA, being the smart people they are, once you apply all that power, you have no clue what the asteroid is going to do. It might break up, and a significant part would actually reach the Earth faster. Maybe all those different smaller impacts will have much more damage. So they figured out, well, if we do like just a kinetic impactor, basically throw a spacecraft at it that doesn't explode, then we have much more control about what happens to the orbit of the asteroid. And we will be much more certain about the positive impact of that change that we're making. And this is basically how I think it ties all together. It's like there are these extremely powerful features that allow you to have big impact. And but impact, asteroids, anyway. But often it's better to choose the simpler system that has a better defined, easier result. And then we can all easily read your code better and have a better future. And that's it. Thanks. So any generic questions, or are we all rooting for lunch?
I guess lunch it is.
Yeah! Thanks.
Cool. Thanks, everyone. Give another hand to Bart Enkelaar. Yeah. So, we're going to have lunch now for the people at home. Enjoy your lunch as well. When we get back, 12:45, there's going to be 2 talks. On the stage next to us, there's going to be interactive development with Kotlin. And on this side, we're going to talk about architecture, or the right architecture that can help you migrate to Kotlin. Make it easier. All right, enjoy.